This is section 3.6. We're going to find the marginal distribution function. We did find it in the previous video. And then the conditional probability. We also saw how to find these functions. So what we're doing now? Well, now we're actually finding the probabilities that we want. Let's see how this works. Finding the conditional probability is 3.5, but actually finding the probability is 3.6. Imagine the following. We have a bivariate, meaning x, y. There's a function of x and y, whatever the function is. In this example, we want to find the probability that x is less than half, given that the y is half. So this is what I say that the y is locked. It's locked in half. Okay? So here, given a function of xy, x squared y, this function was covered in the previous video. And this is the domain of y. Well, if I say that y is half, then I want to find the probability that x is less than half. What you need to keep in mind, if x is less than half, then I'm going to do gx. Okay? So here we have the function of xy is given. The pen is pointing to it, and there is a number 2 here. The function 2 of y is 7/2 y to the 5/2. We found this function previously. In the book, page 151, 3.6, you must solve problems 7 and 8. It's going to take a while. It's nothing you can do in 10 minutes, or even in 15 or 20. Page 144, review example 365. Your job is to show all the work, because the solutions are there. Okay? Function 2 of y, you are given the function of x given y. This is the function of x given y. And you want to find the probability that x is greater than 9. Well, you're going to integrate dx. Okay? Given that the y is 5, so you must go to this page, 144, see the range of x and integrate dx from 9 to the top number, and you must find this value. If you can't find this answer, you did something wrong. Now, let's walk through this example. Here are the steps. Function of x and y is given. Function 2 of y you find by integrating over dx. Okay? You're integrating a double variable over dx in order to find the function 2 of y. When you set up your integral with the function of 2 variables divided by the function of y here, usually, not necessarily, you do some simplifications here. The simplifications are actually made even simpler because you are going to plug the y into all the y's. You can simplify the variables first and then plug, or you can simply plug and simplify the numbers. Okay? Now note, because the probability is that x is less than half, then we're going to do dx, right? We're adding all the way through this interval. Now, you may be thinking, how do I know this number? Because I need the limits of integration. Well, let me explain this. We saw in the previous videos that the graph of this bivariate function is this graph, okay? And then I'll show you very briefly how I found this number in the next page. But we're going to find this lower limit of integration. Do this, simplify, plug half for all the y's, and in the end, if you double check with your calculator, you're going to have simply this. This is what you're going to integrate over x. You can do that, and you're going to find the answer. I'm asking you to do at home and try. You're going to find the probability that y is greater than half. Look at the graph, look at half and the 1. We know that the y goes from half to 1. So you're going to do a dy half to 1. You're going to get into the function and plug a quarter to all the x's. Here's the function 1 of x. We found this in the previous video as well. You're going to plug a quarter for all these x, but also a quarter for this x squared here. And then you solve, and then you must find this answer. It means that the shaded area here is 1434. Now, let's go ahead and do a real example using this. We want x less than half when y is half. Well, we know that we need xy. Here's the function of xy. We need the function 2 of y because the y is the conditional. That's why we need that. Okay? And we found this previously. And here's the range for y. Now, we know we have to do the x. So the question becomes, what is the lower limit of integration for the x? Well, what happened is that x is less than half, so this line is passing on this intersection point. So the x is not minus 1, it's some other number. Here's how you find it. You know that this is a quadratic, so y equals x squared. I don't know x, but in this intersection, y is half. So I put half for the y, and then I square root both sides to eliminate the power 2. And the x is actually the square root of half, which is this. And this is how I found this intersection point. Okay? You will have to find intersection points for all the problems, actually. Now, how do we do it? X is less than half given that y is half. Okay? Here's half for x, less than half. Okay? And y is half. Y is cut in half. We need function of xy divided by function 2 of y. Here's xy. Here's function 2 of y. I simplified because 2 over 2 goes down and 5 over 2 becomes 3 over 2, and you get this number 1. In other words, after I plug half for the y, I'm going to end up with numbers here and x squared. Now, you go on your calculator and you plug half into this y, punch it in, and you're going to get 0.8081 x squared. So at this point, we're going to do dx, because remember, we're trying to find probability that x is less than half. We have to do dx.